Hello and welcome back to A Better World. This is your host, Mitchell Rabin, and I'm very glad you're joining us again today. Today we are going to be having a show on sustainability and green technology. It is obvious why this is so important to our society at this point in time, because we've been ravaged by the use of fossil fuels, and it has not only done damage to our environment, it's also done damage militarily across the world, economically, socially, and politically. And this is really what you could call a dinosaur type of method of energizing and electrifying and transporting in our society. And the fact is that there are some fabulous innovations that have taken place over the course of the last 20, 30 years. And we have one of the main inventors of a windmill technology that the world has not yet seen. And we are largely premiering that here on A Better World for you all to see, because this has been kind of undercover in development, research and development, for the past several years when I first learned about it. But recently, the inventor, my guest today, Richard Steinke of Receptor, called me out of the blue and said, "Mitchell, I've got it. We've done it. I've completed all the research. I've now got prototypes, and I'm ready to go onto your show and tell the world about what we've got." It's really a revolutionary, and I like to prefer to say evolutionary kind of technology that will really allow us to shift the nature of the grid so that people will become more energy autonomous, if you will. EA, I think I'm going to coin that. And it's actually amazingly important to move in this direction for lots of reasons, and we'll get into that during the show. So it's really my pleasure to introduce you all to Richard Steinke, the CEO and of Receptor and the inventor of the technology I'm talking about. And we'll learn about it as this show goes on. Good to have you, Richard.
Well,
a pleasure.
You too, and thanks for inviting me, Mitchell, to the show. We have communicated for the last couple of years.
Yeah.
And
you were on the radio show a few years ago.
That's right, and I told you I wasn't ready to bring out the technology at that time and had to be well tested. And but I've just completed the tests actually December the 8th and got all the results December the 10th. And repeated these test results many times, and so I'm ready to go.
And what are you using? So I'm so glad, and the world is glad as well. But let's look at some of the tests, and then we'll get into the technology itself. Right. When you say it's been tested, what does that mean?
Well, you know, it's very difficult to test a windmill. You would think that it would be simple enough to do, but you don't have enough sustained winds at different mile per hour winds in order to do, you know, a sensible test. So I came up with an idea of putting on the windmill on the flatbed of a truck, and you drive the truck, you wait until a day that there is no wind, and then you take that truck down the road and you actually take it 5 miles an hour and record it 10, 15, 20, up to 50 miles an hour and do recording of it. By doing that, you get everything done within a period of an hour or a half hour, and you have results. Then you can repeat it. And this way, you have exactly the winds. Everything recorded.
So in other words, you can calculate for the wind variability.
Oh, yes, different. It's exactly
and then average.
What it is. In fact,
yeah.
It's actually the perfect test when you're testing a windmill, because you can see
it's real time
results, right?
Real wind conditions,
right? And then we use a test equipment called the Dranitz 4000, and it's used by all the utility companies in testing labs. So I bought one of those.
Standard piece of equipment for the field,
right? And I bought that, and it's hooked up, so it tells you your amps, your voltage, and the amount of wattage that you get at each mile per hour that you say, okay, this is the point that I want to say what we received, because you press a button and it gives you about 13 different readings. So it's a best, most powerful tool, and it's something that anybody can come out and drive along and witness. So
But
it's verifiable.
other engineers and scientists, that's what I'm really looking for,
Right.
can see that testing data and
I've
say,
had many.
well, we can now compare this to ours
Oh.
and see the difference in efficiencies because, let's make the point to our audience that efficiencies are really the thing that distinguishes one technology from another, one, in this case, windmill from another.
Well, I've done many technologies. I have over approximately 50 individual patents in 4 to 5 different fields of technology, and it all comes down to proving it. I always say the proof is in the pudding, so it's very
Let's
true.
have some pudding.
It's true. So what I do is I have to prove to everybody in the world, especially in the alternative energy field, this kind of technology, the efficiencies, because the efficiencies in alternative energy today are not good. Our problem is, you really have a technology in the windmill industry which is under 20% efficient. And
So when we're talking about the standard windmill, this is usually the result of Siemens or GE or the other major corporations that have been making them for a number of actually decades at this point. Yeah. And when we drive down the road in Palm Springs, for instance, or even outside Vegas and elsewhere, we see these large wind farms with these 3-bladed things. What are we looking at, and why are they so ugly, and why are they so inefficient, and what are you doing about it?
Well, really it comes down to the design is incorrect. They have 3 blades up there.
So it's largely a design issue.
It's totally a design issue. I was called in to assess windmill technology 7 years ago by one of the contractors in Europe who actually installed the large windmills and actually maintained them. And he put on a conference in Lucerne, Switzerland, and I was asked to study it and assess what's wrong with windmills because he was very much involved in it.
And they knew they had problems.
Well, yes, that's why he asked me as a technologist to assess it. And so my conclusion when I went over there, it was approximately about 500 people, and the conference was about 6 days. My conclusion to these gentlemen was that they had the wrong design and they had the wrong material of the blades.
How was that received?
It was not well received. Of course, I had about 500 people. I had about 490 boos and hisses. But after it all subsided,
But they knew they had a problem.
They knew they had to. Well, the contractor knew they had the problem because he had to install them and maintain them.
Oh, they were investors.
They were investors. They were professors in universities. They were developers who installed them and wanted them. And but what happens is, and as of today, you can see because of the design, the inefficiencies. So the primary.
Describe what the inefficiency is when you look at one of these 3-bladed.
Okay. Well, the primary
systems.
inefficiency is as you look at the windmill today, the wind blows through it. 85% of the wind blows through that system. So there's no way you can have an efficiency of much more than 20%. And there's just no way. Just with that
It blows
design,
past.
It blows past
It doesn't
the blades.
get.
So it does not.
It doesn't
capture the
capture
motor forces of the wind. So to do that, you have to have a design to capture it, right? So you got to cover more of the wind pattern in order to do that. And that is what I did with the wind sail receptor design.
It could either be wind sail or wind umbrella. I mean, take your pick.
Well, you don't want an umbrella.
Mary Poppins,
because basically that will give you lift, and you don't want to be lifted off the ground.
Of course
not. What you want to do.
Kidding. I was just using a cinematic image. But
the reason why I called it wind sail receptor, it's a wind machine.
Yes.
It's a sail because the design, the final design that I came up with is a sail just like a sailboat. It receives the wind, and the reason why I threw it as threw the last word in receptor because it does receive the wind. The wind blows over the blades. I have 4 blades. I have many more square inches of blade that's the wind is hitting, and therefore when the wind hits that, it turns that into torque. So I have torque.
And explain to the audience what torque is.
Well, torque, and you usually, in their design system, they have 3 blades, and they have a generator, and they load the generator against the RPMs. They have much higher RPMs than I do, so they have a lot of RPMs, and they take and load the generator against the RPMs, and it hits it, smashes up against the RPMs, and that creates the torque. Whereas
the torque meaning the twisting, the power itself.
The power itself. And that
the
creates
movement,
the energy,
the revolution,
the electricity, right? Mm-hmm. Whereas my blades actually create it, and the generator is, I take the load of the generator and spread it out, making it lighter loads because the torque of the blade takes over. By doing that, you actually...
So the torque that might have been generated by the generator is now being picked up by the blade itself.
Exactly.
It's not even a blade. That's not even the right word for what you've got. You've got a sales series.
That's right. That's right. But, in that environment, you would
use
call
that
it a blade. Right?
Yeah.
And, but that's exactly the difference. And it's not just the material. I mean, I could make a composite material also as a blade, or metal, right?
Right.
But to be functional, to be...
It's better that it be like a jib, on a sailboat.
Right. Yeah, but you're not just holding the wind.
Right.
The design allows the wind to blow off of it. And it goes off at a 45-degree angle. So circumference, all 4 of my blades are working together. I have 4 blades, not 3, but I have 4 blades, and the wind blows off of it at a 45-degree angle. In theirs, it just blows through, and then it corkscrews. So you don't want that. It's not efficient. And I capture at 5 miles an hour, I'm capturing 85% of the wind. At 10 miles an hour, I'm capturing 95% of the wind. So at 11 to 12, I'm capturing 100% of the whole wind power.
And not only that, but if I may make the point, Richard, your system is beginning to capture the wind and generate power from it, even as little as at 1 to 2 to 3 miles per hour. Now, it's not a whole lot. Maybe it would give the light for a light bulb. But if it accumulates and it builds, and it's significant.
It's significant because theirs doesn't really start until 15 miles an hour. Then it can run down there at 8, 9 miles an hour after it gets in motion. If the wind falls below that, then it stops and you have to wait again to 15. So ours starts at 1 mile an hour. You really start getting a good energy. It starts around 5 to 6 miles an hour, and a really good recorded energy. So the more you cover the wind area, and the more, for example, if I put 5 blades on there, which I've done, I get more power down lower. If I put 6 and I can go up to 6 blades, I get even more. So I am more than maximizing.
And there's enough room for 6 blades.
Yes.
6 sails on this boat.
Sails. And remember, it all comes down to square inches picking up the wind pattern.
Sailors would love this.
Right. Well, they will.
I mean, really, it's there.
We have a 3-foot design, and it's already a 2-kilowatt unit, and that's extremely powerful.
So if we really kind of step back and listen, I mean, you've made a really good case for the advantages of the system that captures wind through a sail design, and the weaknesses of the existing designs to date. And in other words, why wind sail Receptor? Of course, it's your company and it's your baby, and so I understand that, but there's science that shows. It's funny because on one hand, it looks like it defies physics, some people would say, because of what's called the Betz model, but maybe we can explain, you can explain that. And yet on the other hand, it's actually very simple to understand. I mean, this is sort of like wind technology for, I don't want to say for idiots, but I understand it.
Yeah. Well, when you come out and actually see one of these in operations, and we have them in about 8 different countries right now, and the prototypes out there have been testing for over a year.
You've got these in
And
Paris,
I got in Paris and Rome,
Rome,
in
Belgium.
in Mexico, in India, China.
I tell you, we
in
need
the
one
US.
here in New York City.
Yeah. Well, I know it. You're going to have one of the first shipments in, you'll get one.
Okay, fine.
Okay. But the thing about it is it all comes down to efficiency. You have Bett's law. Bett's law says that you can. There's so much energy that hits a circumference of a wind pattern, and let's say against a block wall.
A wind, yeah, okay.
Okay, and then there's so much energy there. And Bett's law, Albert Betz, a German scientist, says, okay, there's so much of that you can convert into energy.
Is it sort of measuring the impact of wind against a thing?
Against the thing. That tells you the amount of energy that's in that wind pattern. Okay, so let's say that's the 100%. So Albert Betz comes by and he says, okay, with the existing designs, we can come up with a formula. And what is the amount of energy that you can actually collect and turn into energy, the forces, the wind forces, and turn into energy. So they say 59%. Okay, I say it is totally wrong, because in there you have to look at design. If you change the design, you change the whole component of the argument.
You have to have a Betz Jr. for a new design.
No, the thing about it is it's totally false to begin with, even against the existing design. The wind blows through. The existing design cannot get more than, if you're lucky and every thing goes perfect, the most you're going to possibly get is 25-26% efficiency. That's it. Because they're not capturing the wind. It's going through. If 85% of the wind goes through the system, how do you capture it?
You could say it's just breezing right by.
In Bett's law, they say even you can get the wind after it goes through. Well, it's total nonsense.
How?
That
defies physics.
That defies physics, and that's the point. It has nothing to do.
It's like
whatsoever.
capturing words that have already come out of your mouth.
If that was true, and you had all these engineers and all these people and all these major companies working to do windmills, they should be doing 59% efficiency.
And they don't even
so
reach.
So it's not true.
That. Okay.
And so
I get it.
Really what we need to do is do what I did. And I told them at that conference, what you need to do is go out and do a different design. Engineers totally redesign it, because it doesn't work.
Look at the difference between Edison and Tesla, just as an example. One started with DC and one moved into AC, and it was obvious there was a design problem.
There's an
engineering and a design problem. Right. It's a very important point.
You always have to push the envelope. You can't accept what is. Right,
That is an incredible good rule of thumb.
Right.
Exactly.
And then you have to prove it.
I want to come back from this. Exactly, you have to prove it. You can't just say, I have a better design and that's it. And why? Because it's mine. Right. You have to prove it according to certain standards of the industry.
That's right.
Exactly.
Well, not of the industries. You can write new standards, because that's what we're doing. We're actually writing new standards.
You have to start somewhere.
Right. The goal in science is to perfect whatever you do. And the magic number is 100, right?
Yes.
It'll never change. So if you're putting something into the marketplace that's 20 and under, that is not even close to being a product that should be sold in the marketplace.
Exactly. That should not be sold, in fact, if it's only going to be. It's sort of like medicine, but we're not going to go into that, where you get results for that's its own subject. But to come back, and let's look at the practical implications of everything that you're doing, Richard, with Wind Sail Receptor, because that's where people live. They live by turning on a light or turning on the computer, and we pay an exorbitant amount of money for this, and it's only going up, and it's really hurting people's pocketbook, and these economic times in which we live are not good. We're also dealing with issues having to do with the upcoming and imminent solar flares, and this is all documented that these are coming, as they have come periodically in time toward the Earth. By the way, solar flare activity is happening all the time, but it's going to be coming at the Earth, and this has been scientifically verified. It's happened before in 1859, in 1921, and it's about to happen in 2012 to 2013. This could, in our current grid system, knock out life as we know it. That's really what we're looking at.
Right.
It's profoundly serious. Now, one of the reasons I'm so interested in what you're doing is it allows individual residences to have access to power generated from their own wind blowing over their roof, basically.
Right.
And I think that this is a very powerful implication for all of us to digest and understand that we can really be the author, if you will, of our own power. It's an interesting metaphor not to mention. Could you talk a little bit about that and what you have in mind for the world in this regard?
Well, everything, when I invent things, I like to finish everything. And I really believe that, you should go towards self-containment, where you can control your own destiny in your own home and have all the power out there that you need, right? So basically, we've invented the windmill, and that's the system that will start the chain of events.
Oh, yes.
The second thing that you need to do is really look at the storage and get the storage correct. Today, you can go onto the grid, which is fine, and you can reverse the meter, but and that's okay for the time being.
Yes.
But later this year, we will introduce through Wind Sail Receptor actually a storage technology which is much better than battery storage. Let's take battery storage as an example. Right now, it's about 50% efficient. Now picture that the windmill gets 20% efficiency, but now your storage is only 50% efficient. So you're getting 10% of the amount of energy, right? So with our system, we're well into the 90s with ours, and if we use
at that rate, we're going to have to start going like this to generate energy.
That's right. So and with
Ride
our
that
energy
bike.
storage, we would be with batteries. We would be 90-something% efficient with making the energy, and then if we stored it with batteries, we would end up with about a 50%. So 50 versus about 10, right? Okay. That's still not good enough for me. So I push in the envelope, and I want another kind of storage.
You're hard to satisfy, aren't you?
100% is always the goal. So what we're doing...
No, I agree. I think it's fabulous.
Right.
From a scientific point of view, you're right on the target.
Right. Yeah. Well, with what we're doing right now and the technology that we're developing right now, by the end of the year, we will have a storage system. And I want it to be where we only lose 4 to 5%.
Are you going to be using a flywheel for that?
I don't want to tell you because we have the patents to file, but I'm telling you that with your people I'm working with on the generator and with some other people I'm working with, we will have the generator to capture it. To make it. We will have the generator to store it, and we will reverse it and have a motor to meter it out to the house.
Beautiful.
And that's what you got to do. And it's got to be where our technology right now is for the masses. USA is only 5% of the market or less. The world out there needs the technology I just developed to create the energy, and they need to store it. So this is for developing countries. I've been working in China. I've been working in India with those people, and they already want my front-end technology. They want the windmill, and they definitely want the storage, because that is what's going to open up the outer areas of the world and your islands where they're paying 70, 80 cents a kilowatt using fuel.
It's crazy.
This is going to really bring it down to where it's, first of all, it's common sense. When you see the design that I've done, as soon as you look at it, you say, oh, so
why
simple.
didn't I think of that?
So simple.
Right.
But everything that works is simple. There's no complexity.
Exactly. No, that's a very, very valid point. What I hear is that there's the storage and then there's the generator, and they both have to be highly compatible with the with your particular system.
Right.
And, of course, we've talked about the
Well, that was
KLD
that's
generator.
been my problem,
and
right?
That's been
For the
your
last,
problem. And
3 years.
I think we've got that solved with the
Right, got it
KLD
solved.
generator. And, when you put it together, because see, another thing I want to say, we're going toward closing here, but you have also made the manufacturing efficient. Now, the big giants right now have waiting lists of some 2.5 years, and if you are able to make what are called blades, they're not really blades, but your wind sail receptor system in a matter of seconds or minutes, which is phenomenal because of an efficiency in your assembly line, you're going to be so far ahead of the curve, no pun intended, than anybody else as well.
Right. Well, that's what it comes
I mean, that
down
way
to
you're going
is-
to have the greater impact in the world that you're really seeking. And, I really would like to make this point to our audience that so much of the, and by the way, what you're doing, Richard, it's beautiful. It's not only beautiful from the heart because it's such a beautiful gift to humanity, but physically, aesthetically, we're going to have windmills on the landscape, in our environment, populating it. And, they actually blend in. They're green. They're beautiful. I mean, they
are
they
very, very
enrich.
beautiful.
As far as something like that goes, I feel that they enrich instead of borrow from.
Plus, no noise.
And no noise.
Zero noise.
And is there any vibration?
No. Because
And
it
nor with
works-
our generator,
it
by the way.
actually dances with the wind, right? And not rock and roll dancing, it actually classical dancing.
I think it's the walls. Richard, this has been fabulous. I want to just thank you so much for your good work and for being on the show today.
Well, thank you, Mitch.
Absolutely. It's such a pleasure. As you see, this is science in service to humanity and entrepreneurism in service to the world. And that's the way we're going to shift our planet, because things as they're going now is the wrong direction, and we have people like Richard Steinke and others that are out there who are doing what they can to change the direction of this ship so we can survive and survive well and sustain our society instead of destroying it. Thanks so much for joining us. Visit us at www.abetterworld.tv, and I love your comments, your feedback, so please get in touch with us, and I look forward to seeing you next week.